Hello and welcome to another lesson of math with Ms. Murthy today. Today's topic is tables of equivalent ratios. This is lesson 1.2 in Reveal Math, 6th grade. And as you can see from down below, this starts on page 13 of your book. As usual, I'd like you to pause and do the talk about it, think about it, and the check problems on your own. So today's goal is to look at using equivalent ratios, and we'll use tables to find equivalent ratios. Now, this table shows the ingredients that we need to make the dough for one pizza. Right? We use 2 cups of Greek yogurt, 3 cups of self-rising flour. Now, we use this information to find the number of cups of each ingredient needed to make either 1, 2, or 3 pizzas. By maintaining the ratio, we're going to maintain the same ratio. Okay. So if you look at the bar diagram to the right, you can see how the ratio of 2:3 is maintained, right? So you can see that over here we have each of our blocks representing 1 unit. So we have 2 units of Greek yogurt and 3 units of flour. When we want 2 pizzas, now our unit size becomes 2. So we have 2 times 2 units of Greek yogurt and 3 times 2 units of flour, which still maintains the same ratio, right? So now the ratios 2:3 depicted down below here, 4:6 and 6:9 are equivalent ratios because they express the same ratio relationship between the quantities. So if you don't recall, the meaning of equivalent is equal in value. Okay, so 2:3, 4:6, 6:9 are all equivalent ratios. Now, a table of equivalent ratios, or in other words, the ratio table, is a collection of equivalent ratios that are organized in a table format. Each column has a pair of quantities that have the same ratio as the pair of quantities in the other column. So if you can see, our rows here are Greek yogurt and flour. And then our columns represent 2:3, 4:6, and the 6:9 ratio. Now these tables show both an additive structure and a multiplicative structure. Let's examine what we mean by that. Okay, when we are adding the same quantity, like here we had 2, we added 2 to it. Whereas for flour, we had 3 and we add 3 to it. The same base value, we are adding the same base value of 2 and 3. That gives us our additive structure because we are adding. Now in the table in the bottom on the slide, you can see from one step to the next, you're multiplying by a different factor. Over here, we multiplied by a factor of 2, multiplied by a factor of 3. The bottom row also, we are multiplying with the same corresponding factors of 2 or 3. This shows us a multiplicative structure. Now, the process of multiplying each quantity in a ratio by the same number, where you multiply the two quantities, in this case, Greek yogurt and flour multiplied by the same number, is called scaling. Okay, we can use scaling to extend the ratio table to find the number of each ingredient that we need to make additional pizzas, right? So we could multiply by a factor of 4, by a factor of 5. And we do it to both the ingredients. We multiply both the ingredients by the same quantities to get us the equivalent ratios. So you can see from that table, to make 4 pizzas, we need 8 cups of Greek yogurt and 12 cups of flour. To make 5 pizzas, we'll need 10 cups of Greek yogurt and 15 cups of flour. So 8 is to 10, 8 is to 12, 10 is to 15 are also equal to 2 is to 3. Let's take a look at example 1. To make yellow icing, Amida mixes 6 drops of yellow food coloring with 2 drops of white icing. How many drops of yellow food coloring should Amida mix with 8 cups of white icing to get the same shade of yellow? So let's make our table first. We're going to create a ratio table with the information that was given to us. We know that for every 6 drops of yellow food coloring, there were 2 cups of icing. So let's make that table. Drops of yellow icing, yellow coloring versus cups of icing is 6 is to 2. Now in this case, we want to know how much should we mix with 8 cups of icing, and we don't know how many drops of food coloring to put. If you examine this table, you can see to go from 2 to 8, we have to multiply by a factor of 4. So if you multiply the drops of yellow food coloring by that same corresponding factor of 4, we get 24 drops of yellow coloring. So again, like we said, because 2 to 4 is equal to 8, multiply 6 by 4 to get 24. So the ratio 6 is to 2 and 24 is to 8 are equivalent ratios. So Amida should mix 24 drops of yellow food coloring with 8 cups of white icing to get the same shade of yellow. Work on this on your own. I'll show you the solution in a minute. There you go. All right, let's look at example 2. Aquino mixes 3 sample containers of yellow paint with 4 sample containers of red to create his favorite shade of orange. His sister, Aiko, wants to create the same shade of orange paint, but she only has 2 sample containers of red paint. So what should Aiko do to create the same shade of orange paint? Let's make our table first, the ratio table. We know that for every 3 containers of yellow paint, there are 4 containers of red paint. And at the end of the day, we don't know the amount of yellow paint that we need to mix with 2 containers of red paint. Now, how do we do this? So far, we've practiced going forward. If you look at it, 2 is nothing but 4 divided by 2, or 4 times half, right? So we could use that same relationship working backwards. We scale backwards. 4 to 2 is divided by 2. So 3 divided by 2 would give us 1.5. So Aiko should mix 1.5 containers of yellow paint with 2 containers of red paint. All right, do the check problem on your own. Here's the solution. Now let's take a look at example 3. This is on page 17. We probably now would have to do scaling in both directions. Natasha made a raspberry punch for a party by mixing 9 fluid ounces of fruit punch, 3 liters of soda, and 6 scoops of raspberry ice cream. Halfway through the party, the punch bowl was empty. If Natasha now only has 6 fluid ounces of fruit punch left, how much ice cream does she need to make another batch of punch? Let's examine this. We create a ratio table, and we're only looking at the 2 ingredients we care about, right? So we know that for fruit punch, for every 9 ounces of fruit punch, she used 6 scoops of yellow ice cream, right? And we now know at the end she has 6 ounces of fruit punch. We need to know how much ice cream she needs. Now we know that there is no whole number by which we can multiply 6 to get to 9. There is no whole number that gives us the relationship between 9 and 6. So we are going to do this in stages. So let's scale back from 9 to 3. To get from 9 to 3, we're going to do a divide by 3. So we do the same for the other ingredient that we care about, in this case, ice cream. So 6 divided by 3 gives me 2 scoops. Now, to go from 3 to 6, I'm going to multiply this by 2 and therefore multiply this by 2. Let's take a look. There we go. So now we scale forward to go from 3 ounces to 6 ounces. That will give me time multiplied by 2. And I can multiply my other ingredient, the ice cream scoops, also by 2 to give me a total of 4 scoops. The check problem on your own. Here you go. All right. Now we're going to use a double number line to find equivalent ratios. It's very similar to the equivalent ratio table that we just saw, and you'll see how that's so. The ingredients needed to make 24 biscuits are shown on the table. If Portia wants to only make 18 biscuits, how many cups of flour does she need? So what is it that we don't need the information here? We don't need milk. We don't need eggs, shortening. We are only looking at flour. So we don't need any of this other information, right? We're going to use a double number line to solve this problem. A double number line, like the word says, has 2 number lines in which the 2 coordinated quantities are the equivalent ratios. Let's draw a double number line. We have 2 number lines. When there's 0 cups of flour, obviously the number of biscuits is 0. But we also know that when there is 4 cups of flour, she can make 24 biscuits. So we scale back and we're going to divide 4 and 24 to get that factor of 1. We divide both of them by the number 4. This gives us a ratio of 1 cup of flour gives me 6 biscuits. So from here, I can extrapolate the values for 2 and 3. So if I have 2 cups of flour, I'd get 12. 3 cups of flour, I'd get 18. Do the check problem on your own. All right. I'm going to pause right here. Please practice the check problems on your own, and we'll talk about the apply problem in class. Catch you in class. Bye-bye.